Hi, I'm Johan Joubert and welcome to the AnyLogic Modelers YouTube channel. I was recently privileged enough to be invited to do a presentation to the third year industrial engineering students at the University of Pretoria. The topic of the lecture was my choosing, and I decided to use some content from my future training course, Advanced Modeling with AnyLogic, and we decided to do a lecture all about the life cycle of a simulation model. Now, although I use AnyLogic to do some of the examples of the theory and concepts that I explain, the principles discussed are all generic and in my opinion should be applied to any simulation project. We discussed the life cycle of the simulation model by looking at the 7 steps, in my opinion, that every simulation project would go through, from defining the problem, working with the data, building the model, verification and validation, doing experiments, analyzing the results, and reporting on your findings. I hope you enjoy, and a big thank you to Johan Joubert for inviting me to do this presentation.
I think let's reconvene again. Thank you so much. Jacobin, I see you've joined us. Welcome. It is a real privilege to have you as a guest lecturer. Jacobin has been an alumni of our department, a former student both at the undergraduate and master's level. And Jacobin, you will probably say something about kind of your journey, especially in terms of simulation so far. I wouldn't want to urge you in terms of typing messages in the chat box or questions. You have the raise hand function as well. Jacobin, you can indicate when and where you want these questions, kind of whether you want to hold them for the end.
Okay.
But other than that, again, thank you so much. I think the students are eager to learn a couple of exam tips in terms of how can they approach a new problem that they've never seen before. And you've done this a couple of times. So I'm going to switch off my camera for now to give you all the bandwidth you want. And again, thank you so much for presenting.
Okay. Excellent. Thanks so much, Johan. So good morning, everyone. It's a privilege to be here today. I remember not too long ago being in the same place where you guys were or are now. Probably not exactly the same, because you guys get to do this from home where we had to still go to class. But in any case, today I want to talk to you guys about the simulation model life cycle, and probably more specifically about a project, simulation project's life cycle. We're going to do it from start to finish. What's the best practices and the practical advice that I could provide you guys, at this time in my journey. So I'm Johan Joubert. I'm the co-founder at the AnyLogic Modeler, and for the last decade, I've been doing simulation models at various places. We started off working for BHP Billiton. I still do a lot of work at Goldratt Research Labs, where we focus on helping people make better, faster decisions when it really matters, and simulation is a key part of that. If you guys want to contact me or follow us for the AnyLogic Modeler, you're welcome to visit the website or contact me via the various social media networks. Okay, so when I first thought about what to present today, it was a bit hard, thinking what I would have liked to see when I was third year, when I was doing simulation. And in the end, I decided to give a brief overview of what you would encounter in a real life simulation project, right? And how much does it differ from what you'll be doing in undergraduate level. And I also took a lot of the parts from an upcoming online course which I'm creating called Advanced Modeling with AnyLogic. So the topics we'll be covering today is all about the different phases that you will go through while you're building your simulation model and doing your simulation project. So first off, we're just going to start with defining the problem, right? And then data. Data is key. Garbage in, garbage out. How do you work with the data? How do you data drive your model? And then the big part is building the model, right? The actual work that we like to do is the coding, the animation, the analysis part inside the model. Then we're going to move over to verification and validation part, a crucial part of any project. We're going to look at setting up some experiments, analyzing the results, and reporting on the findings. We're going to be using a very simple example. I'm going to show you some of the concepts and how can you easily apply that inside AnyLogic. We're going to start off simple, pick up a lot of speed until we get up to the experimentation part. I'm going to show you some advanced tips and features inside AnyLogic, and then we're going to slow down a bit for the analyze the results and the finding. There might be some advanced stuff which I'm showing. You guys can get a copy of the slides afterwards. And just know that, as long as you know these things are possible and you know what's the concepts behind it, the application can be very specific based on your model, the specific project, etc., and your knowledge of Java and AnyLogic. So with that, here's like a first question. Before you can start with a simulation project or simulation model or any project for that matter, what is it that you guys think that you need? What's a crucial ingredient before you can start a project? You guys are welcome to raise a hand or type something in the chat. I'll read it out loud. Okay, we've got people saying data. Okay, defining the problem, right? So those that paid attention to what I was about to describe when I described the presentation content is the problem, right? So that's, we don't just do projects for the fun of it, we do enjoy it, but you need a reason for doing a project. And most of the time there's a problem. There's something that you need to solve. There's something that needs solving. There's some benefit to solving it. So the first step, and I've divided this defining the problem into actually 3 phases. The first part is just talking about the problem, right? And you need to be very specific. You need to talk about who's got this problem. Like, what is the problem? Where are they experiencing this problem? Why is it a problem? Why is it important solving this? And in being an external examiner for the university for a while now, I always find that people neglect the why. Like, why is this a problem? There's a lot of things which you can define as a problem and it can be solved, but like, why is it important to solve this problem? Usually there's a monetary impact, or maybe there's some social or environmental impact, but there must be some negative impact that we're trying to negate or minimize by solving this problem. And be succinct, right? But be very specific in what the problem is. And now for a little cartoon at the bottom says, good solution, Dave. All we need now is a problem. Now, remember, if the only tool you know is a hammer, everything will look like a nail. So once you've defined your problem, really take the time and say, is the solution that I'm going to be applying to this problem, or the tool that I'm going to be applying, is this applicable? Is this the right tool for the job? So, we all love doing simulation, but not every problem is specifically useful for simulation to be solved with. So we're going to assume now for this case that you've done that work, you've proven that simulation is a good tool to solve this problem. Now the next thing is we need to define a purpose for our model, right? What is the objective of your model? And obviously it must be to either solve the problem or to help whoever has this problem get enough information, get clarity, get some insight so that they can go and solve the problem. Usually this is at a bit of a higher level. So you're just saying my model must be able to do this, right? You don't go into the specifics of exactly how it's going to do this, but at the end, if you ask your question again about your model's purpose, at the end of the project, and you say yes or no, right? Did it do this or did it not do it? Not exactly how did it do it, but was it able to do this? Okay. And once you get to this part, you're saying, well, this is my model's purpose. What do I need to achieve this, right? So what is the scope? What are the boundaries? What am I going to be modeling and what am I not going to be modeling? Don't try and boil the ocean. You need to start small, but keep the big picture in mind. If you follow some of the best practices and advice that I'm going to be giving in this session, and you build your model with a good architecture and nice modular design, you'll be able to start small and easily add on to your model. If you start too big, it is incredibly difficult to cut out sections of your model and still keep it working, right? So it's easier to go big. It is much more difficult to go smaller. And be specific. Scope creep is real. If you ever work for a client, or even if you're just doing a project at your place of work, you'll realize that as soon as you start building stuff and people see what you can do with the simulation, or they've got some ideas, you'll soon realize that everybody keeps on asking for more and more things. Now, if you've got your scope properly defined, you can communicate to the client or to the manager saying, listen, this is outside of scope. I think this is going to increase the original deadline or the budget or whatever of the project, but you must keep track of these things. So let's look at a simple example. Let's say there's a retailer and they've got 2 cashiers in their shop, or in the retail shop, and they've got a separate queue for every server, right? And recently people have been complaining about the average queue waiting time, right? Once you get into a queue, you can't jump the queue and go to another queue, and suddenly you see that the guy in front of you is taking much longer than expected, and now you feel like, I should have gone to the other queue instead. And so one of the managers of this retail shop says, listen, why don't we just make use of a single queue, multiple server setup, right? So we've got our 2 servers and we've got everybody waiting in the single queue. So if anybody is being held up for some specific reason, opening a new account or issues with their account at one of the servers, they won't hold up that specific queue, right? And now the manager of the retail shop says, okay, this is awesome, but it's going to be very timely for us to test whether we want to do this and how it will work. It might be very costly, right? If we might have reputational damage if this doesn't work for us. We need a safe environment to go and test this. So they approach you, they approach some consultants to say, listen, we need to test this out in a digital twin, in a safe environment. We need to get fast feedback. It must be low cost to implement and test. So let's go ahead and let's go and define our problem first. So I've already started here. I've got 2 options. Any comments on which option is the better problem definition? So option 1 says a retailer wants to investigate the option of moving from a queue per server setup to a single queue for multiple server set. So a retailer, option 2 is a retailer wants to quantify the impact on the customer average queue waiting time in their shop when moving from a queue per server setup to a single queue for multiple server setup. Which one do you guys think is the better example of a problem definition? Okay, I see a lot of option 2s coming in. Great. So what is the problem with option 1? If anybody can type real fast. So in my experience, the problem is this word investigate that we find in option 1. Like, what do they want to investigate? Is it floor space utilization? Is it environmental impact? Is it social distancing, right? So we're not saying exactly what their problem is. They actually only care about the average customer waiting time inside the queue. If we had our problem definition as they want to investigate like the impact of moving from option A to option B, people are going to come and say, listen, but we said that's what we want to investigate. Why can't you measure, the distances between customers waiting in the queue, etc.? So you need to be really specific, and we've specified this as it's just the average queue waiting time for the customers. Okay, so let's talk about the model objective. Again, I've got 2 options here. Option 1 is saying the model must be able to simulate the customers arriving and queuing in front of the servers, or queuing in a single queue and then being served, right? So the model must be able to simulate the 2 options. Or option 2 is we're saying the model must be able to accurately measure the changes in average customer waiting time between a queue per server setup versus a single queue per multiple server setup. Which one do you think is the best model objective? So taking in mind that at the end, we would like to have the model be able to solve our problem, right? So Prof Joubert is saying at the start of the semester, we talked about modeling life cycle. We said you should have a specific scenario in mind or a specific metric option. So option 2 has both a scenario and a specific metric. And I think that's key, the specific metric. If we are saying that you need to have, just simulate, what are we going to simulate, right? We can simulate anything. We can just have them walk up there, do whatever. It's very ambiguous, right? At the end, you're going to say, did you simulate this? Like, how do you answer yes or no to that question? Where if we're saying accurately measure the change in average customer waiting time, that's something that at the end, somebody can very objectively say, yes, we managed to do this, or no, we did not. Okay. And additionally, what I typically add into the model objectives is to have a little bit of a phased approach, especially if you're working with a big model. And so I've oversimplified it for this example, but we're going to do the same. So I'm saying here the model will initially only sample from historical customer data, and later we're going to generate random customer data, right? So I'm having a simpler objective to start with, like we're only going to sample from historical data, and later on we're going to generate our own data. So let's talk about the model scope. So option 1 is we're going to say the model uses historical server data for the customer arrival. So when did the customer arrive? How long did they take to have to be served at the cashier or the server? We're going to model the service as a delay. We're going to measure the customer waiting time in the queue. So that's pretty cool. I mean, we can add a lot of stuff in there. And what about option 2, where we add in some additional scope, right? We're saying each product in the historical customer order will be modeled individually. So we're going to have products as agents sitting inside the customers. Customers will occupy 3D space in the queue based on their trolley or their basket, or they've got a bag, the number of products. We're going to have a 3D layout of the shop, right? So what is the problem with option 2 if we're saying that is too much scope? Right, so option 1, it seems pretty cool. It's got exactly the things that we need to answer our objective. But in option 2, we're adding a lot of additional things. And the question you must ask yourself when adding anything inside scope is, obviously we've got some answers here, relevant data, right? That's exactly right. Is it relevant to your objective? Is it relevant to the objective you want to meet? So customers will occupy 3D space, right? If our objective, if the problem was about social distancing, and our objective was to accurately measure the impact, on one customer to the other based on the social distance, right? Whether it's going to be something COVID related or not, then we would have had to have this inside scope. So you must. It's good to say these things will not be in scope, and then your answer must be they will be irrelevant. They will not add to the model's objective. And if they are in scope, you're asking yourself, will this help me meet my model's objective? Okay. So let's talk about working the data. So little cartoon here saying, before I write my name on the board, I'll need to know what you're planning to use the data for, right? So it's probably a stab at all the privacy policies that we're experiencing nowadays and the privacy of information. But this is real, not just for personal information, but any company information. If you want to get information about customers, what they bought, what's their queue waiting time, you really need to prove to whoever in the organization is going to give it to you that you will be using this for a legitimate purpose. Like, what am I using it for? Why? What's the project? What's the objective? And luckily, we've done all that work in phase 1. So the first thing about working with the data is first just getting the data. And you have to use your scope as guideline, because then you can take it all the way back to the problem, right? I need this data. Why? Because it's in the scope. It'll help me achieve the model objective because I'm trying to solve this problem. Now, when you ask for data, and this is sort of just the practical advice side, is that you need to get more, if you can, get more data than what you need, unless it's going to, dramatically or significantly increase the retrieval time. So, which is often not the case. If somebody needs to get a data dump out of the system, you just tell them what columns you need, and they'll go and write the query and get the data. But if you tell them I only need, these few columns, and then a couple of weeks later I need more columns, and I need more columns, it's going to be the same amount of effort for them every time almost. And it's always easier to not use the data that you've got than to ask for more later. So just a practical piece of advice. And then when you get the data, validate the data. Do some exploratory analysis on it. You'll be surprised how many times, I've gotten data, it seems fine, I start using it, I start making changes to the model, I'm trying to figure out if there's a problem in my logic, just to realize that there's some data input errors, right? So really take the time before you use the data to make sure that it's correct. We'll do an example now. Now, the next very, very important step, which is often neglected in beginner models, is to data drive your model. You've got the data. Now you need to put it into a format that you can use inside your model. And ideally, nothing must be hard-coded. And everything inside your model must be data-driven, right? You must have your source data, and that will determine the customers that arrive, their service time. In bigger models, it must determine exactly how many objects you create, how many locations, etc. So ideally, how we would do this, and I'm going to show this in an example, is you must make use of a data object, which is like an intermediary between your source and your model. So you've got your source data, which can be anything, and then you've got your data object, which you provide to the model, and the model will build itself based on the data contained inside this object. So let's have a look at the collecting of data, an example. So here's a little Excel sheet that we then got from the retailer. Can anybody tell me what issues? There's 4 issues in this thing. Can you guys comment on what do you see as the problem with this data? Okay, so I think the easy one first is the customer ID. It seems like most of them are integers, and we've got one here that's a string. So the question is that erroneous data entry or recording, or is there something special to do with that customer? Anything else? There's a negative time. That's correct. You can also see there's some hashes there in C12. So that's also the problem, the arrival time. So there's negative values, there's incorrect data values, and also the format in column B. Yeah. And so, yeah, I see somebody commenting about the time. So this is a 24-hour shop for the purposes of this. And there's an inconsistent date format as well. And then there's a special bonus one here at B10, which is in 2000 instead of 2021. So simple issues like this, you'd read in the data, there's 500 customers, you run the model, you get 499 customers. You're thinking some customer got stuck in the system. You run the model again and again and again. Meanwhile, there's just an entry point, which is outside of your model's start and end date, right? So let's assume that we've cleaned out the data, everything checks out, we've done a little bit of analysis on this. And obviously don't need to tell you guys that this little bit of analysis that you do, don't just manually do it inside something in Excel, but if you do, it must be totally reproducible, because you'll be getting new data and bigger data sets and next year's data and the previous year's data, etc. So don't do anything that's once off. Okay, so now we're going to talk about data driving a model, and this is the key first part in building your model. And so there's several ways to data drive your model in AnyLogic. We're going to look at two of them now. So the first one is that you read directly from your source files, right? So in AnyLogic, there's a nice set of objects. There's the Excel file, there's the file object, and the database. So file can be anything, like a text file, which is CSV, tab separated, whatever delimited file you want. It can be XML, etc. And yeah, I've just got as an example a little while function, which is going to cycle through each row inside this Excel in a specific sheet 1 in column A, and it's going to, and B, C, and D, and it's going to do something with it, put some objects inside a rack, right? So you can basically very easily do that, take the data and populate something in the model. What I personally like is to import the data inside the internal AnyLogic database and then use it from there. You guys have definitely seen this inside some of the tutorials, especially in the supply chain ones, where you've got a lot of data, you typically import it inside the AnyLogic database. And then there's a number of blocks that have built-in database functions, right? So for example, the source block, you can select that the arrivals are defined by a table. We're saying the order data, we're saying the arrival time, right? So we can easily source our customers from the AnyLogic database. But what I do want to be showing you today is a little bit of a more advanced way, which we'll get to now. And just a pro tip, so because AnyLogic is based on Java, and I think that's one of the key differentiators for them in the simulation world, is the fact that they use Java as the underlying programming language. That means you can import data from any source, right? You can use web APIs, you can import things into JSON objects, XML objects, etc. Everything that's available to a normal Java programmer is available for you to use. But remember that the way that you source your data greatly depends on the model environment, right? If you have something that's going to be run on somebody's desktop, it's probably going to use an Excel file or a text file. If it's run off a server, it's probably going to use a database or might use some web API, etc. But the problem with this is that because there's so many different ways of sourcing the data, and that it actually might change during your project lifecycle, right? So what happens is somebody gives you an Excel file, and you go, oh, this is awesome. I imported into AnyLogic database, super cool. There's an easy function for that. Then they say, listen, Excel doesn't have enough rows. We gave you 1 month of data. Now we want to give you the whole year's data, and there's not enough rows inside Excel. We're going to give you a text file. Then you go like, okay, I need to change things now. How do I get inside the database? And then they say, okay, we can't do your database anymore, the text file anymore. We have to give you access to the database. Right? So things change. And how you can prevent this from having you to actually change your logic blocks, right? So if we don't use the AnyLogic database anymore, then the source block will need to be reconfigured. Now, the way to prevent that is to use a data object. So the best practice, like I mentioned, is have a separate data object that drives your model. This allows for you a separate place where you can verify and validate your input data, right? You get all the data from the source, you have a look at it, make sure that all the values is exactly what you want. If there's some setup or some initialization that you can do inside your data, you can do all of that inside that object. So it's great for manipulating the data. It's a lot easier for setting up unit testing, which I'll show you an example of now. And what is really cool about this is if you split your source from your data object from your model, you can now take your source file, create data objects, give it to your model, and have multiple models running in separate threads, all in parallel without a connection to your source data, right? So this makes for executing complex and scenario comparisons a lot easier. And this also encapsulates the setup data into a single manageable object, so it's a lot easier to keep track of what data was used to run what model. And so the typical workflow that we follow in our model building is you've got your raw source data. So it's either Excel, text file, database, whatever it is, doesn't really matter. And like I said, I personally always try and get it inside the AnyLogic database. And the other option is to just move it directly into your data object. So what we've created here for this small example is I've got a little Java class here called Scenario. I'm not sure how comfortable you guys are with programming in pure Java. So this is just a very simple Java class. And I will show you the example when we get into AnyLogic. And you take all the data in your Excel file that's inside your database now, and you create a data object and you populate it with whatever the data is. And then inside your model, you've got a single parameter object, which is of this type, in our case, scenario, which is of the type of your data object. And you just provide that to your model. Everything that the model needs to build itself is actually encapsulated inside that one object. Whereas you might know, if you use, if you want to add parameters to your model, you need to add them as actual objects to your model. You have to specify where they're being used. Then you have to go to your simulation object and you have to link your variables to those parameters. It can become a nightmare in especially big models. So have a look at how I've done this. So in this very simple example, I've got a selection box where you can click and you select your Excel file. And I've got a little button there that says import data, where we're going to import the data into the AnyLogic database. Then once it's inside the database, we create a scenario object. I've got a little button here for us to do that as well. And then we just provide this data object to the model. So I've got a very small video here just showing that. So select the Excel file, click on import data. I've got a little message box saying it's available, get scenario. You can see there's our scenario. Click play, and the scenario is passed on using a parameter. Great. So now that we know that we've got everything inside our model to data drive everything else. Okay, so that's a very crucial first step. So the next step is the fun part, where we get to building the model. So a key lesson here is always to start off simple. Start really high level, and then you go bottoms up, right? So you start with your top idea first. This is our entire system. As you can see here, we've got source, we've got queue, delay, and sync. So customers are arriving, they wait in the queue, they get service, they go out. We make sure that this is working. And then we gradually build in more detail until at some stage where we've got customers arriving, we've got what queue type are we currently simulating? Are we doing multiple queues per server, or a single queue for every server, right? And we still have our sync and our original source block. Now, a key thing about building models, and this is neglected, I think, in simulation models too often, is that you really need to test, and proper testing. So you need to test after every feature that you add inside your model. So I'm saying I'm adding in an option to choose which queue to pick, like this pick shortest queue, right? Build a test and make sure that it's actually working. This is something very simple now, but for something more complex, build a test to make sure that it's working. And once you've tested that individual feature, then you need to test the integration of your features, like test all the features that you built previously. Are they still working? Do they work when you add this feature as well? So in essence, the model building process is a very circular cycle. So you add a feature, you test that feature. You do an integration test, and you test all your previous features. And then you move on to adding new features. Okay, and a nice quote from Prof Johan is about model building rarely has a right answer. You need to just start doing something, and that in turn will reveal the next hurdles to revisit, to redo, to dig deeper, right? And a lot of time I find myself looking at the model and going, okay, what's the right thing to do here? And I've got some ideas, and I can rely on my experience and my expertise, and say, I think these things are going to work better. But in the end, you don't know until you try. So in our example, how this is currently set up. So we've got our customers arriving. I've got a little setup customer arrivals function here that creates dynamic events based on the data contained inside the scenario object. And every time this event executes, it's going to inject customers at this customer arrival point. And depending on what scenario we're currently running, they will either go to this server per queue setup, or it will go to the single queue per server setup. And this little enter blocks that we've got here, as soon as somebody enters in the queue and one of them are available, it will take themselves out of the queue and go to that specific server. Or if there's people standing in the queue already, and whenever the server finishes serving a single customer, it'll pick up one from this queue and make it enter into their server block. So a big pro tip, and this is something that not a lot of people do, is to completely split your animation from the logic, right? Separate agents if possible. And there's two big reasons for it. The first one is probably more practical, and that is that if you have a lot of animation inside AnyLogic, a lot of graphical objects, and you've got your logic, or any amount of objects in just one agent, the IDE becomes super slow, right? And there's such a lot of things to draw on the canvas, it just becomes impossible to make changes and to navigate around. And I think anybody that's built a warehouse model with tons of conveyors, or any other thing where you've got a lot of graphical objects, it has experienced this, it becomes really, really difficult. So the way to do this is to completely separate your animation. The second objective here is that your animation must be completely decoupled from your model logic. Technically, you should be able to make just a model run and then choose whether you want animation or not, right? Now, it is a little bit difficult. Some of the AnyLogic blocks completely rely on the animation. So they say, well, what is the distance I need to travel? You know, it's defined explicitly, or it's defined by what you've drawn. And there's things like pallet racks and some pedestrian objects which rely on what you've drawn to define the logic, right? Okay. So let's talk about doing testing. So we've got our model, it runs, we press the play button, it is actually doing something. So if you do proper testing, you are required to test each feature individually. You're required to test multiple features. You must be able to store all your tests, right? It's not something that, oh, I just quickly create this Excel file or this, you know, set it up manually with parameters, press the play button, okay, it works, and then I move on, right? Because the idea is that you need to be able to rerun your tests again and again to ensure that previous features that you've built has not been broken by new features that you add on. So your tests must be reproducible. And if you can, and this is sort of the best way to do it, and I'll show you an example of how we manage to do this, is the ability to run automated tests. Now, if you write unit tests and you write proper unit tests, you don't need to check your work, right? Why is that? Because the unit test does the check for you. I often start off in some of our bigger models where we add new features. I first write the unit test to say, okay, I want resources to be able to move away from their current work and do something else. Okay, let me create the model where I give this command. Okay, I can see the resource is not moving away. So the test is failing. Let me go and build that functionality. And I keep on working on this functionality until that test passes, because then I know the work that I did now is doing exactly what I wanted. And then I click run all to test that all the previous things that I've built is still working as expected, right? And if they're not, I know that something that I built now works for me on this example, but it is breaking something else elsewhere. One thing to know is that test is a great way of documenting your model's features and functionality, especially if in big models, if you come back to your model, or if somebody else works on your model in the future or works with you concurrently, if you've got tests defined to say, you know, these are the things that my model can do, this is how I test for them, right? This is how I set it up, and this is the variables that I change, and this is the results that I expect to change. So it's really a great way of testing that. So let's go and have a look at an example. So something that's maybe a little bit advanced and something that's not often used is the custom experiment object inside AnyLogic. So if you create a custom experiment, what it's going to do is it's going to like run your model, but without any animation, right? So that's really useful if you're doing a unit test, because you don't want that animation. And secondly, if you learn a bit more about Java and you're able to do threading or multi-threading, you'd be able to create a thread, run your custom experiment. Now, the custom experiment allows you now to create a separate custom experiment, a separate model, and then run that model. So what I've done here is, you'll see here, I've added 2 buttons to my simulation page. And you'll see the benefit here of using that scenario object. Now I'm just going scenario, right? I'm creating a new scenario object. I'm saying scenario.add some customer data, and I'm creating a new customer data object, which we'll have a look at now. So I'm creating 3 customers, 1, 2, and 3. So this is their ID. And I'm saying on what date did they arrive? So I'm taking the current date. And what's their server time? How long did it take them to be serviced by the cashier? So 20 minutes, right? I'm adding 3 of them. And then there's another parameter which is saying multiple queues set up through. So there's multiple queues for the different servers. And I'm just saying custom experiment, create a new custom experiment, don't worry about this argument. And then I say custom experiment.start round. And start round is a function that I created inside the custom experiment. And I give it the scenario. And what's going to happen is that the custom experiment is just going to be executed, and I've got some trace lines in it, which is going to help me see what the results were. Okay, so let me just get to the specific one. So I just want to show you our scenario object, very plain old Java object. It's got a list of customers, which is of type customer data, and there's a function to add customers to that list. And our customer data, you'd recognize these three elements are the three columns inside your Excel file. So typically when we build this, every sheet inside the Excel file would be a Java class, right? So, and then every row inside that Excel file will be an instance of this class. So if this is a bit too high level and you guys want to, build more Java knowledge, there's lots of courses online. I've got one as well. And this will help you to understand maybe what I've written here. So let me just get to where we are in step 3. Just get to the simulation. So, just to show you this import data function, very simple. I'm just taking the Excel file and putting it into the database, and this get scenario file, get scenario function, as I showed previously, is just going through the rows in that specific file and giving you a scenario object. So this unit test that I've shown just now, before I run it, what do you guys think is the answer is going to be? So I've got 3 customers in this setup. They're each going to take 20 minutes. So what's going to be the maximum waiting time? What's going to happen? We are going to have our first customer, like all 3 customers are going to be arriving in the queue at exactly the same timestamp. The first one is going to be served. The second one is going to be served. And the third one will have to wait in the queue. So what is our queue waiting time going to be? Any guesses? Yep, I see 20 minutes. So I literally click on this button, immediately I get the answers, little trace lines that I've added. So the maximum waiting time is 20. And the average waiting time would be, there was three of them, 2 waited 0 time, 1 waited 20 times. So maximum waiting time 2. And I'm going to run this other test as well. And I mean, you can have hundreds of tests here with little buttons, right? And what we typically do is, now I'm just tracing out the results. But what you would do is inside this result, and we'll get to that in some of the next sections, is you actually want to have some checking. You want to say, well, if the result is 20, give me a trace line saying that the test passed, right? And some pro tip is that you can actually use JUnit, which is a specific Java library to do your unit testing. So all this code that we've got inside these buttons can actually be put inside a new custom experiment, which you'll see here. I literally copied that code in here. And inside this code, what this custom experiment will do is actually just executing that code, calling the other custom experiment. But the nice thing about this is if you click here on your play button, you'll see I've got for this model, I've got run all UTs, run all unit tests. So if I click on this, it's immediately giving me, where is it now? It's immediately giving me the answers for all my unit tests, right? Because if you've got hundreds of unit tests where you're testing individual pieces of logic, you can run all of them with a single click here. So typically while I'm building, if I'm finishing up anything, I just quickly run all the unit tests. Yes, everything is still passing. I didn't break anything. Oh, my new piece of functionality is unit test is not yet giving me a true result. Okay, so I need to work on that. So now we get to the nice part, verification and validation. We've built our model, the features is working as we expected. So the joke here at the bottom says, I'm too dependent on external validation, but what do you think, right? And when it comes to models, your model must be that guy, right? You need external validation. So trick or bonus question for everyone, what is the difference between verification and validation? So, so let's start off with verification, see if what you wanted to type was correct. So verification is whether you check if it does what you designed it to do, right? So this is checking the quality of your model, testing, you're doing some inspection, design analysis, etc. And this is great if you get also an external colleague or some other modeler to test your work. So typically you would use unit testing, your animations, maybe review some of the outputs, etc. And this is relatively objective, right? You're telling the person to wait 20 minutes, then move to a location. After 20 minutes, does it move? Yes or no, right? There's no, either it works as you want it to or not. So if we look at validation, this is checking if it appropriately matches reality. And immediately using the word appropriately, it means that it's obviously more subjective. So we're checking against our historical and expected outcomes. We're using all our detailed reports. And we know that we can never match reality 100%, right? It all depends on the environment, the time frame, the reliability of your input data. If we get, in our example, we get that we're modeling the exact historical customer server time, etc., and we're finding that we're getting, average queue waiting time of 5 minutes versus reality for 6 minutes. You're going like, is this good enough? Is the model accurate enough? Well, it depends. The input data, did we have to remove a lot of the entries because they were not usable? No. Was there load shedding? Was there any issues there? Was there a manager at some stage that helped some of the people jump the queues, whatever the case is? And are we simulating just a month? Are we simulating a year? This is very subjective in deciding whether your model's results are valid or not. Okay, there's a proverb, I'm not sure who said it, I couldn't find anything, but it's saying trust is good, check is better, right? You can trust that you did a good job with your model, but checking to make sure that the results are what you expect or what other people expect is a lot better, and checking it in detail. So let's have a look at an example here. So one way to do the verification, to do the validation part, is to output detailed logs of your model. So in our model, I've added a little text file object here inside the model. It's called customer queue time. And I'm initializing a header inside of it. So I'm just printing a line inside of it, queue time. Now, I personally like to use the text files. It's sometimes a lot easier to use compared to the Excel files inside AnyLogic. And you can always just right-click on a text file and say open inside Excel. Now, how do you output detailed results to the text file? So inside our sync block, I'm calculating the queue waiting time. And then I'm saying customer queue time, this text file, .print line, the queue waiting time, right? So every customer that exits the system will then have its queue time written out to this file. And then you just have to remember that at the end of your model, you need to close this file so that you can actually open it on your machine, else the data just stays inside buffer. So the nice thing about this is you can write as much data as you want to the log file. It doesn't actually consume the Java virtual machine in which your model is running. It doesn't consume that memory. And a little pro tip is that you can add a little download button to your front page. I always do this. It makes it easier not only for me, but for customers as well. Because every time that I run this model, this customer queue time text file will be overwritten, right? And I don't want to explicitly have it write out with a different file name, because while I'm testing, I'll get hundreds and thousands of files, right? Whereas if I just download the ones that I need, in your download folder, it will automatically add an additional number to it to give it a unique name. Okay, so if we have a look at the next phase of our model, I'm just gonna run it. So step 4. Okay, so the first step here is that we can upload a new Excel file. Just give me a second. So I've got my little Excel file here, which is the same one that I showed in the beginning. I'm importing this into the model. The nice thing about the AnyLogic database is that even without importing this, the previous values still exist inside the database. So I'm just getting the scenario object. So here's the scenario object. I'm going to hit the play button, and we can see here our model is running. As soon as they start going through the sync, I'm also recording that exact same value that I'm writing to the customer time, queue time. I'm also writing to this nice histogram. Right, so that's really cool. And you might ask, but why write it out to the text file if you've got the data here inside this histogram, inside the model? And the big problem with anything inside your model is as soon as you close it, it's gone, right? And you don't want to have to send people screenshots or copy and paste this elsewhere. You just want to have it available afterwards so that you can send them that data, and then you can create the histogram inside Excel, Power BI, Tableau, whatever you want. Okay, so I'm just going to let it run. Currently, if the model gets to the 500 customers, it closes. It closes the model, so it navigates back to the simulation page. And you'll see this little download button here. If I click on it, because this is running in a browser, you can see that it's downloaded here. If I open up this, you can see, oh, it's a nice text file with all my data. If I decide to rather open it as such, yeah, I can open with Microsoft Excel. And here's the data. Nice, usable. We can do lots of histograms, charts, whatever we want with it, right? And this is then the data that we can now use to validate our model, to compare it against reality or the actuals that we had. So we've got our customer waiting times. Now, how do we compare against reality? So 65 minutes average waiting time versus 60 maximum time. Incredible. Not a very good shop. You can see why the people are complaining. 233 minutes versus 240. I've drawn some charts here. How many customers had a waiting time between 0 and 10? How many customers had a waiting time between 240 and 240 minutes, right? So something was wrong with their accounts. There were some issues to be resolved, etc. So yeah, you can have a subjective view about whether your model is accurate or not. Okay. So now we get to the fun part, right? We've built the model. Now we get to do experiments. The cartoon here at the bottom says, I already know the answer. That's why it's so hard to create the right experiment, right? A little bit of tongue in cheek, but a lot of times you need to ask the customer, what are you expecting, right? This new warehouse that I'm adding on, this conveyor, this change, do you expect it to be better or not, right? And you need to ask them this for a couple of reasons. One is they're the subject matter experts. They know their process. They've got good intuition, probably built up through years of experience about what they think the result will be, right? So either you validate their results with backup data, or if you invalidate their expectations, you need to be very sure about your results, and you need to have proper detailed explanations about why that's the case, right? So you need to know what they're expecting so that you can manage your analysis and results that we're talking about next appropriately. So here we typically test the scenarios defined in the objective, as we discussed previously. And if there are no specific scenarios, or you've got the time, you really need to stress test your model to find the boundary conditions, right? So our model can accurately predict the change in average customer queue waiting time under these conditions, right? If there's less than 10,000 customers, or whatever the case might be, right? It's specific to your model. So choose way out numbers and also see whether you can break the model or not. So this requires multiple runs using different random seeds. Our example, we were just using the historical data, right? So there was no randomness. If we ran that model again and again and again, we'll get exactly the same answer. So not very, very intuitive for doing experiments. So in this time, and how I typically do it is, for the outputs, I now create a summary result saying, for this scenario, I ran it 5 times. This is the average, minimum, maximum, standard deviation for each one of the metrics that I want to measure. And I also still keep a detailed results for every replication, right? Because if you see, wow, this one's got a massive standard deviation, is it because all of them are different? Was just one of them different? How do they actually compare? And you don't normally look at them at first, but if you want to, you always have that data available. So the pro tip here is that you need to store your results inside a custom Java class. So you would notice that when we build advanced models, you've got your model in the middle, you've got your source data on the far end, and it's buffered by your data object, and you've got your analysis, which is buffered by a results object. So the model gets a scenario object to populate itself, and it gets a result object to store its results in, right? So I'm going to do a bit of an advanced example here. So we had to upgrade some of the parts inside the model. So first of all, I added a new sheet to our Excel sheet file, and I've added some additional columns to that sheet, and I'm calling it scenario name, right? So I can type in a name for our scenario. We're saying, is it a multiple queue setup? False, true or false. So I've got the little data validation inside Excel here. Use historical service time, true or false. Are we going to read the historical service times from the customer data, or are we going to create our own, right? So this is false. You must have some values in here. 000 would not be great, right? So I'm going to add in some values here for our 2 scenarios that we're going to be experimenting with. And this is a nice thing about your data object, is that if somebody adds in a -1 here or whatever, you can actually in your data object do that check to say, listen, in row 2 inside mobile setup, you've got a negative value in column E. That's not expected. It should be 0 or greater than 0. So these columns that I've added in here, as I mentioned previously, typically every sheet in here is a Java class. On the model setup page, we've got like parameters for running your model. These I normally just add in as fields inside our scenario object. So you'll see inside of a scenario object, we've got our list of customers with their data. But now I've added new field, scenario name, multiple queue setup, historical data, service time, likely service time, the same columns that we've got in here. And inside the function that takes the data in the database and puts it inside our scenario object, I've got these standard select from this table, the first result in that column, right? So I'm putting all the data that I get inside this Excel sheet model setup, I'm putting them inside our scenario object. Okay. Now, the best practice here, I didn't do this just to keep this example very simple, is that all your fields should be private, and you should have getters and setters, right? So you can control who makes changes to the scenario object or not. And now the model uses these fields to create customer service time. So previously in this function, the setup customer arrivals, we were just saying, create a new customer arrival, with the model time to this date. and the server time, right? And the server time was just the customer data.server time. So what was the historical server time for this customer? Now I'm saying if we are not using historical data, then the server time would be a triangular distribution of minimum, maximum, likely service time, right? So now we've got some randomness in our model. So this is how easy it is. I did not change anything on the model logic side. I changed my source data, I added things to my scenario object, and I changed a small piece of setup logic. And everything else still stays exactly the same. Whereas if you were reading these service times, inside your delay objects, you would have to go and change your delay object. Okay. So another thing that we also changed now is the detailed results, which previously was just this one text file inside the model. I've now moved that text file to the simulation page, and now I'm providing it to every model using a parameter. So now I can write out to that file instead of just a queue time, right? Because if I just write out a bunch of queue times, it's just a bunch of numbers. I don't know what replication, I don't know what scenario, right? So now I've got 3 columns there: scenario name, the seed, the queue waiting time. And inside the sync block, I'm referencing that parameter, which is now the text file which lives on the simulation page. And now I've also added in the summary of results. So this is a bit more advanced. Just going over the concept here is that when I click on this run all scenarios button, which you'll see now, it's going through all the scenario files that I've selected. It's importing that data. It's creating a new results class. It's saving that results class with the name of the scenario into a map. And then for every replication that I've said I wanted to have 10 replications, it creates a new experiment and it runs that experiment. And now this custom experiment has grown a bit in functionality. Now we're telling this advanced experiment, here is the scenario that I want you to run. Here's the random seed I want you to use. Here's the text file I want you to store the detailed data in. And here's the results object that I want you to send your data to. This results object would be the same one for every scenario file, because it's going to take replication 1, 2, 3, 4, 5, and then store the data in there in the statistics object, which is going to give you minimum, maximum, average, whatever the case is, right? And once you're done with this entire scenario, I'm writing out this data to a new text file, which I've got. Okay, so like I said, when we're going to pick up speed and we're going to end with some advanced examples, this is where we are now. So if we have a look at the simulation page here, you can see how this has grown a bit. So we've got our scenario comparison here at the bottom. I'm quickly going to run this one so you can see how it works. Okay, so this new scenario comparison functionality, I'm using some standard Java things to select like multiple queue and single queue. These are the 2 scenarios we want to run. I mean, I can select the base scenario as well. As many scenarios as you want. I'm going to run 5 replications. We could type in anything here. And now I'm going to click run all scenarios. Now it's going through that little piece of code. It's saying, here's the file, here's the seed, here's the results, everything. Great, scenario comparison successful. We can now download the results. Here's our results map. And the results class is a simple Java class as well. Now I can download my summary results. I can download my detailed results. And if we have a look at our detailed results that we've downloaded here, this summary here, I'm just going to open it inside Excel. Let's just do some, you can do some formatting things before you actually write it out. And we can see for our multiple queue setup, the average customer waiting time is actually slightly higher than our single queue, right? And if you look at, there's lots of research done on this. This is kind of expected. The one thing here, though, is that we only had 2 servers. The more servers you have, possibly the more profound the impact can be of the average waiting time between multiple queues and single queues, as well as the distribution, right? If you've got a triangular distribution of between 1 and 2 minutes and with a maximum of 15, that one time that that customer of a 15-minute server time is actually in the queue for a lot of customers waiting specific, it's going to delay them considerably. Okay, so once we get here, now it's onto the easy parts. We've got our output files. We can say, well, this is what it looks like. Here's the results. Is it what they expected? You review it with the client. You look at the results details. We've got the details. Now we need to go and analyze our results, right? So So what is the data telling us? Well, as of at this point here, we know we're no longer on speaking terms, right? So you can only talk to the data as much as you have data. And the nice thing about the simulation model is that you can go back and add in more data as you need it. So a couple of pointers to remember about when analyzing the results is that you need to remember the model objective, right? What are we trying to measure here? I didn't output data about the customer's distance from each other, etc., like that. Our objective was to measure the average waiting time in the queue. And so that is what we need to analyze. Some practical advice is always look at the data from various angles, right? Try and measure it in this way. Try and display it in this chart, a scatter plot, a bar chart, line chart. So use various analysis techniques, right? This is a super simple model, but there might be some linear regression. There might be some pivot table or some grouping or some normalization that you can do. And always double check your results with the experts, right? And the experts is typically the people working with this process. Like I mentioned, they've got intuition built up over years. They've got a good idea of what it should be. And they should be able to give you, reasons why your results is not making sense, or why, yes, it does actually make sense. We've experienced this in the past, right? And always ensure reproducibility in your analysis, like with everything you do. Now, a key point here is that if you want more data in the simulation model, just go and add it. Okay, so here I said, here's our analysis. We are just going to show you, exactly what our objective was. The delta between the multiple queue and the single queue on average queue was minus 1%. On the maximum on average, it reduced by 5%. Now you can go back and say, did the model achieve its objective? Yes. Right. And now you're ready to go and report on your findings. So Cartoonia says, I actually have nothing to say, so my presentation would only last an hour or two, right? So be sure you've got something to say and keep it succinct and make sure that it is prepared and tailored for your audience. So I typically use the pyramid method, where you start off with the final outcome and then you've got supporting statements. So you're saying, well, we were sent to measure the average queue waiting time, and we found that will be reduced on average by 1%, and the maximum queue waiting time would be reduced by 5% on average, right? And then the questions would come, which you've obviously prepared for, and you've got supporting statements, and you've got supporting slides for every statement that you've made. And this is key, especially if you're presenting to executives and managers. You start off with, this was my finding, and this is the reasons why. If you're talking to the guys on the floor, right, not to diverge the conversation too much in the beginning, you start off with, this is what we were asked, this is how we do it, and you take them on your journey and you say, this is what I landed up on. But more often than not, the pyramid method works fine. Thank you guys so much. This is really, I've enjoyed creating this presentation. It was a lot of work, and I hope you guys enjoyed listening to it as well. If there's any questions, you're welcome to type them up. I'm not sure, Johan, do they get to answer as well?
Joubert, thank you very much. Yes, I see there is a question already in the chat box. Can I ask that you use the raise hand function if you actually want to ask your question kind of verbally and don't necessarily want to type it?
Yeah, I'm just going to answer this one from Christopher. It says, for the data input, would someone have to record the queue data themselves, or would it be acceptable to use a typical distribution if a lot of research has been done in that area? And I think this really depends on the environment. Is it practical? Would you have somebody standing there? Maybe in today's day and age, you can use cameras to monitor when somebody enters the queue and tracks them when they get out again. This really depends on the impact of being wrong or being right? So I think for this specific example, typical distribution of the average queue waiting times would be good enough.
Great stuff. Joubert, I was just kind of curious. You may have partially answered it, but I think you and I have probably built up quite a bit of Java experience over the last couple of years. What would you recommend? Because clearly one can really get into the thick of things and really kind of exploit the deeper benefits out of something like AnyLogic if you scale up your Java competency. What would you recommend in terms of your experience? Where should a student maybe knock on for advice or register for a course or something? What are there a couple of pointers from your side? How did you go about improving your Java skill set?
Yeah. So for me, the first thing was there's such a lot of free courses available on Java, and you would start up, and then you're going to learn a lot of Java. You can see how this is really going to help you. You don't understand the difference between a linked dash map and a linked dash set, and then you take these courses, and the first thing they tell you is, okay, install Eclipse or IntelliJ, and this is how you do this, and you write main to get a program. You're like, I don't understand how this works. And once you manage to go through that setup and you learn all the Java programming part of it, and then you get to the actual code, and then you can use that code inside your AnyLogic model, it's actually a long journey. So that's specifically based on my experience why I created this course Java for AnyLogic, which is purely focused on the Java parts that I've used out of personal experience to build better models inside AnyLogic. So this course is available on Udemy, and you guys can contact me and I'll provide a discount code. So I'm a bit promoting my own course here, but that's definitely what I've found is to be the best. As long as you can get over that initial hurdle of understanding Java, then the next time you've got a question like, yeah, there must be a better way to keep a unique set of items inside a list. You literally Google that, you go to Stack Overflow, which is where most of the questions and answers are. And you say, oh, okay, I need to use a hash set. This is how it works. There's other websites, I think Baildung and so on, which gives you the answers. But the problem is you don't know what is available. And it will take you years, as it did me, to wonder, is this possible? Search for it, go past all the standard Java jargon, and then get to the piece of code that you can actually use as is inside your AnyLogic model. I see we've got one question here. What's the biggest hurdles you experience in the simulation model lifecycle? So I think in my experience in the beginning phase, when you need to get all the data, get the right data, understand the data, and that's mostly because unless you've got a dedicated team on the client side, or if you're building a model in-house, for the people that's joining you, is to get that right data. And that typically slows down the process in the beginning. And that's probably the biggest hurdle to overcome. And then if you get to the verification and validation phase, and you're finding issues like where the results are not matching up, with an acceptable level of error, and you then have to ask questions. But why is that the case? But this wasn't in the data. You never told me that they do this once a year maintenance, and that's why the numbers are lower. That's the two parts, right? So in the beginning, definitely the biggest hurdle, and then if you've got problems at the end, it's typically very time consuming to fix them and get the right data. Somebody's asking about how long is the course. I think it's like there's obviously an amount of hours in it, but it's like how long is a piece of string. So as long as it takes you to go through everything and complete all the things, but it's about 5 hours worth of video, and then there's lots of assignments and questionnaires which can take you, I think there's about 4 assignments which will take you about a half an hour to complete. But as you can see, it is definitely worth it. The amount of time I've wasted in building models where I put in thousands of parameters inside my model object, and then go back to the simulation page and create thousands of variables, and then link those variables with the parameters on the simulation page. And just doing things in an awkward way where it's already been solved. Java is a technology that's been around for many, many years, and it's been improved so much, and that you can be so more efficient. And again, that's like for me, the biggest benefit of AnyLogic is having this powerful language underneath, which allows you to do almost anything with it. So I'm seeing somebody saying they would love to do something in as a final year project, but wondering about the learning curve of Java. So Johan, I'm not sure how are we on time. Can I tell you a slightly longer story?
Well, I think you will probably see it in the number of students reducing drastically. I'm not sure whether they have, maybe if you can just indicate through agreeing or disagreeing, just let us know. Do you have a class now at 9:30, another class? Yes, okay, so there are a couple of them that that indicate they have another class, but I am recording this, and the recording is available afterwards. So, I mean, if you want to, I think let's carry on, and if the students then want to come back and revisit and just check out the last bit, then they are welcome to come back to the recording. So yes, please go ahead.
Yeah. So, I must say, when you are younger and third year and second year, or even final year, you probably don't have the benefit of hindsight of seeing how much you've gained in experience and in life lessons by learning new skills, right? So for Christopher, when I was in my final year and I wanted, I spent so much time learning Arena, and I had to, like, I was doing a project in third year, was in Arena, and then in final year, when Prof Johan was our professor again, and I wanted to do my final year project with him, he said, listen, he's not going to help me if I do Arena. He doesn't know anything about it. He suggests I do AnyLogic. And I was going like, oh, but you need to know Java, and I've got all this investment, which is a sunk cost of my time inside Arena. I don't want to do this learning curve, right? But when you get to your 30s and your 40s, you realize that learning curves are just a part of the game. Like every new thing that you learn, it gives you the ability to learn faster, to learn newer things, to learn better things, etc. Right? So I remember back then I still went to Nadia and I told her about this dilemma, like, should I do this? And Nadia is an alumni as well. I'm not sure if she's still at university. And she was talking to me about how she also did this and she studied this big book of Java. And I was like, oh, I want to, like, I was going to do Arena for the rest of my life. And I went on the AnyLogic training course, and I also did some courses on Java. And, look where I'm now. So, and even now, when there's like new things coming along and it's Python and there's even more advanced Java stuff, every time I need to ask myself, oh, this learning curve, is it worth it? And I need to remind myself that probably it is, right? Obviously, be careful about what you choose and where you invest your time in, but definitely it is. It's like learning to touch type. I also thought to learn to touch type would take a lot of time. How is it going to save me? But if you just save 10% of every day that you type, you just save 10% of that, and it spent you days learning to touch type, you would make up that time in the next couple of years easily. No, next couple of months almost. So doing a course about Java or sharpening your Java skills if you want to continue working in AnyLogic is crucial. You're going to save way more time and also in frustration by learning that skill. And doing that decision was the best I've ever made. It's taken me all around the world doing simulation models for various companies in various continents. So it really helps you to just be a better engineer. It teaches you how to think better, how to get better structure inside programming and building the models as well. A bit of a long answer.
But I also think, nobody can ever take your experience in Arena away from you. In the process, you've also learned let's call it the philosophy of simulation modeling. So learning AnyLogic was just an additional skill in your toolbox, right? So and the same will probably hold for programming. You are not, yes, you are mainly a Java user, but you've learned certain coding structures which will benefit you should you ever go on to any other new language that might come along.
Yeah, definitely. I think one needs to keep in mind that a lot of the skills that you learn, right? So don't choose something weird, but a lot of the skills you learn are transferable, right? Or parts of it are transferable. So like exactly what you said, Arena, how do you structure things, how you create nice layout, etc. That skill is definitely transferable. And if you think about like Java, and Java's object orientated, right? VBA is object orientated, Python, etc. So all of these things are object orientated. If you learn the object orientated principles, that's transferable to a lot of things, a lot of other languages and tools that you'll use. So I see there's a number of people asking for the link to the course. I'll provide it here in the chat. This one is a 40% discount. If you guys feel that you need anything more, you're welcome to contact me privately, and I'll share that.
Jacobin, thank you so much. I actually, seeing that there is, mind you, there's one more question. Thank you, that was useful. So you had to learn AnyLogic and Java from scratch in your 4th year? That's a question from Christopher again.
Yes. So I was very fortunate that I had a bursary and they were willing to pay for the AnyLogic fundamentals course, which we did. But back then there wasn't nearly that much tutorials, help, free courses, etc. available on the web and inside AnyLogic itself, right? If you just go through all those tutorials and the big book of AnyLogic, and now I think the AnyLogic in 3 days is also free. And there's one other thing that focuses purely on the process-centric or the discrete event, like the flowchart modeling, is also free. So you can go a long way in learning AnyLogic for free, and you can also go a long way in learning Java for free. The only problem with that Java for free is that it will be based on, building it inside IntelliJ or inside Eclipse or some other platform that is not AnyLogic. But you can go a long way for free if that is a concern or a constraint.
Yeah. All right. I must say, what was really insightful to me is kind of being a strong proponent of unit tests and test-driven development in IntelliJ. I mean, it was very insightful for me, at least, to see that you actually do unit testing inside AnyLogic. So I kind of had a question, but I think you've answered it, and that is how one would actually implement this. Now, maybe just a disclaimer: if you have a 3-hour exam that you need to kind of solve a particular problem, you will probably be more reluctant to actually do test-driven development. So the idea is not within kind of an exam space to also do that. But I mean, for larger, more kind of high-stakes projects, I mean, those unit tests are pretty important. I'm curious just to how would you implement JUnit tests in AnyLogic? Is it possible?
Yes, so I was actually expecting that. So I answered a question on that on Stack Overflow, and I can't find it right now, but I put in a significant amount of effort in answering that. And I'll do a blog post about that as well at some stage, and it's going to be part of the advanced modeling for AnyLogic course. We talk about using JUnit. But for one of our big models, we never implemented JUnit. We started off, just doing the same way that I do now, but you've got hundreds of Java, or you've got hundreds of tests in multiple Java classes. And then inside the custom experiment, the new custom experiment that says run all the unit tests, you just say, well, run this one, run this one, run this one, run this one. And you just check all the results are what you expected. But on unit tests, if I look back at some of the projects I did in the past before I didn't even know what the unit test was, and I would go back to myself back then and tell myself, listen, you need to create tests as you go along. I would say, no, it takes too much time. I don't have time for this. I'm just going to develop, and I'll test this one thing. And if it works, I'll test it with like a new scenario. I'll move on to the next thing. The problem is that you build something, and let's say I'm going to have the functionality to specify some specific feature in my model to do A, right? And then I build B, C, D, E, F, all the way 6 months down the line. The guys are running and they're getting answers. They're running things where they're changing feature A, right? And then suddenly they realize that something broke at some stage. And you say, oh, damn it, it's when I implemented F that I actually broke A. And all this time, A has been broken and we didn't know about it. And now you need to go and fault find and why and fix it. And you actually spend such a lot of time trying to fix things, whereas actually if you implemented F and you realize that the way I'm implementing F is breaking feature A, you would have fixed it immediately. And you would know about this error, because there's nothing worse than somebody coming back and saying, listen, we've made this chain, luckily that has never happened to me yet. We've invested millions of dollars into doing this because the model said so, but somebody looked at it and this doesn't make sense. You go, oh my goodness, it's because feature A is actually broken, and it has been broken for a long time. So if you're building serious projects, there's definitely a level of testing, and if you can, unit testing, that is an absolute requirement.
I don't see any more questions. I guess the students. Oh, there's another one. Yeah, Fidi, I must say
it was. To see what can be done.
It was kind of, I think, but I mean, Jacoben, you did warn them. I mean, you'll pick up speed towards the end and just show them some really cool pro tips in terms of what can be done. And I must say it was very insightful. In that sense. But yeah, the better you are at the tools in your toolbox, the more data gymnastics and modeling gymnastics you can actually perform.
Yeah. And so I see somebody commenting, a lot of Java. And it's actually, if you go and look at the lines of code, right, that I've added, and like importing the Excel sheet and like those things in the beginning, in the first 3 or 4 phases, it's just 1 or 2 lines of code. As soon as you get to the custom experiments and you want to run multiple replications at the same time, yes, there it becomes, you need to understand what you're doing. And just a note on that, I wanted to include it here as well, but I cut it out because it just wasn't enough time. But you can do a lot of these things on the cloud, right? But then you possibly need a subscription. And you can do a lot of these things in a bit more complex way using the other custom experiments that AnyLogic's got, like the parameter variation, etc. But you always have the same problem where you need to output your data somewhere. And so these concepts that I've explained, if you understand these structures and you figure out the way to implement it without, the nice, neat Java code, then that's the way to go as well. So I see people asking access to the slides. I'll give access to the slides. I think that's fine, but I will be posting this as well with the video on my blog with the slides. But the model, I'm still thinking about that.
No, perfect.
But I'll let you guys know.
Yeah. So I mean, if you can at some point maybe just share the slides in PDF format with me, then I can also make it available here on ClickUp for the students. But yeah, I agree. Coming up with those example models. That's creating intellectual property.
Yeah, this was a couple of days' work.
Great stuff. Jacobin, I really appreciate it. Thank you so much for making the time available and putting in the days. I hope you get a lot of return on investment on your examples, and good luck with the AnyLogic modeler. I think it's an amazing venture. I think there's a huge demand for it. So good luck and thank you very much.
Excellent. Thank you guys so much. Really appreciate it.
A big thank you to Professor Johan Joubert from University of Pretoria for inviting me to do this lecture, and a big thank you for the students from the university for participating. If you like this content and want to learn more, feel free to follow us on the major social media networks or to visit the blog at theanylogicmodeler.com for more information. Thank you so much. See you next time.